Okay, welcome to Chicory, creating a language-native Wasm runtime. So, a little bit about us to start. My name is Ben. I'm the co-founder, CTO of Dialypso. Here is Andrea. He's principal engineer at Red Hat. And yeah, I live in New Orleans, Louisiana. He lives in Lisbon, Portugal. And for the past 6 months or so, we've been just kind of collaborating online over the Atlantic Ocean on this on our free time, and finally got to meet Andrea for the first time meeting him, first time doing this talk together. So also he snuck some slides in here to surprise me, which I don't know about, so it's going to be fun.
To keep you awake.
Yeah, keep everyone awake. Yeah, so let's get into it. So first off, why are we talking about the JVM at a Wasm conference? You might be asking yourself. Well, I would basically counter the argument, why are we not talking about it? It's actually kind of weird how little we talk about the JVM. I've heard in a few of the talks, it's definitely mentioned. Certainly you hear write once, run anywhere. You hear a few jokes and stuff. And certainly there's a lot of issues with the JVM, but the JVM was created with the same goals as Wasm in mind, really, if you go look and understand its history. But it has a 30-year head start. So they probably know some things that we need to know. Yeah, there were previous talks that have kind of mentioned this idea of learning from others, and especially the JVM, the people who are working on that. So I would just say, if you're kind of skeptical about the JVM, or you have sort of certain ideas about it, I think if you're working on Wasm at all, you should take the time to go understand it, study it, and use it. Even just using it and kind of experiencing what it's like to use a mature virtual machine like that is enough, but also studying it is good too, and it's not that complicated. Yeah, so second, really, which is most important to this project and why we're talking about the JVM here, is really just the mountain of value that's been created by the JVM. So I want you guys to just stop for a second and just think and reflect on how deeply the JVM has embedded itself into the modern economy. Yes, thank you. Just meditate on that. So again, there's 30 years of JVM software in the world, creating conservatively hundreds of billions of dollars of value nearly across all business verticals. You might even say it's trillions of dollars. I mean, I don't know, but that's reasonable. And just think about all the massive public companies that are just exclusively powered by the JVM. Think about ecosystems like Android, billions of devices all across the world, all powered by the JVM. So, it's huge, right? So, yeah, this is not Wasm Enterprise Edition. This must be an Andrea plant. We're not announcing Wasm EE here. Unless you want to give us a big contract, then we will sign it. Yeah, so what I wanted to talk about was, okay, right. So, all right, so yeah, we have 30 years of software. Great. So why are we talking about the past, right? Why do we care about this 30 years of software? So this talk is largely about embedding Wasm into the JVM, but should we be focused on compiling all this JVM code to Wasm instead? Well, I don't think so. I mean, I think, we believe the reason, the most compelling reason to use Wasm is that it can unlock the full value of your applications by making them programmable platforms. So we think in the future, having a Wasm interface will become the norm for integrations, because Wasm will help us scale the complexity of integrations by facilitating multiple orders of magnitude, more interactions than an HTTP API can. So the basic idea is the more interactions you can do between two integrators, the more features you can extend and customize, the more things you can do, it can unlock more value, more customization. And this is why we think embedding Wasm into the JVM is an important path forward. We can't just leave behind all the stuff that we've done. And there's still lots of JVM software to write in the future as well. So how do we execute Wasm in the JVM today? Well, there are a number of really good mature Wasm runtimes like wasmtime, wasmer, really great runtimes. The only issue is these are written in languages like C, C++, Rust, and they're distributed as native code, which has some pros and cons. So the main downsides here are there's two things really. Distribution. So if you're linking to a native object in the JVM, you have to ship that thing off with your application or your library, right? So one of the main reasons you use the JVM is you compile to a platform-independent bytecode. That's kind of the point. And then now you have like this whole triple of like, dimensional problem of compiling for every, OS and architecture and libc that you need to ship this thing. The other side is on the runtime, right? So to communicate with some shared object on most systems, you need to use some kind of foreign function interface. And in Java, there's a few different like kind of names for that, but it's roughly the same. And there's a lot of complexity and problems when your execution leaves the safety and observability of the JVM. So let's talk a little bit about some specifics about what that is. So if you stay within the JVM boundaries, then you get guaranteed memory safety, which is they've been doing it for a long time. It's a pretty good guarantee. You get fault isolation. There's no if your Wasm program is like JVM bytecode, then it can't crash to JVM, which is kind of a major problem for a lot of applications. You get like a super advanced JIT, right? So you can imagine when you use FFI, the JIT from the JVM just sees the program as a bunch of holes, right? It's just going in and out. But what if it was just all one kind of stream of JVM bytecode? And there's lots of really good reasons why you want to stay within the boundaries of JVM. Yeah, so what do we do about that? This is another Andrea slide, I think. Which I assume what he's saying is we put the VM in the VM, right?
Yes.
Okay, gotcha.
That was the intention.
Yeah, so we put a VM in a VM. Yeah, so the non-joke slide is this idea we're kind of trying to coin called a language-native runtime. So we don't really expect like this type of runtime to like replace the state-of-the-art runtimes, but rather to kind of fill in the gaps and maximize the portability, as well as provide like a better developer experience. So a good analogy that we've kind of thought of is like might be the difference between say an F1 car or in like an off-road vehicle or a Jeep or something, where your F1 car, you're going to get the fastest, the best performance, you're going to have the best technology. The cons are it's not going to be able to run in many places. If it breaks even a little bit, you're in a lot of trouble. Whereas the Jeep, it's very portable, it's simple technology, obviously not going to be the fastest, but it's going to get you into a lot of different terrain. And I could even see a way, something we do in XDism is switching out the runtime where you need it, right? So it's like, if I'm more kind of hostile environment, I might use Chicory. If I'm more in a known performant environment, I might drop to some more performant runtime. So we're not the first people to do this. We kind of consider ourselves spiritual cousins to Wazero, because they probably were the first, I think, one of the first runtimes that kind of pioneered this idea. And credit to Eduardo for this incredible piece of art that should be in the Louvre, honestly. Yes. Yeah, so although Go and Java are very different, like Go compiles to native binaries, Java is this whole managed like runtime, they actually have very similar problems in terms of like having to reach out to native code. So these two projects like kind of have a similar spiritual kind of like connection. And I also think that like this is probably not a problem unique to these languages as well. I could probably like enumerate a few others, but you could probably imagine like when you have a language with a pretty strong runtime or managed runtime, then you might have some of these problems where once the execution or memory allocation escapes that, there can be problems. So we're going to introduce Chicory. Andrea is going to come in and talk about everything we've done and some of the technical stuff.
Thanks, Ben. So it's a pleasure, and today we are introducing our project, which is Chicory. You can find it in GitHub under Ben's organization, Dilipso. So please come check it out, submit issues, join our Zlib channel. We love to welcome you into the project, so please come and check it out. So what happened? this is actually a really, really quick journey because I realized that it was just 6 months that I was collaborating with Ben, and this was a side project for both of us. And what we have been able to realize in 6 months, and the fact that we are here today, is actually really exciting for me, and it was a really extremely great journey. Eduardo from Wazero introduced us because he went from our former common employee for him, Red Hat, and went to work on Wazero. And with Ben, we actually envisioned running Wasm workloads on top of the JVM, writing a Java native runtime. So we really wanted to see those kind of applications being enabled on the JVM because it's something that was completely lacking at them, it was doable. It is doable, but with constraints and problems. And to make it possible in 6 months, we concentrated every hour of our energy on delivering demos and POCs on the happy path, so on integrating and developing how to perform the instructions written in Wasm for running programs, actually. So building a language native runtime. Those are a couple of notes that we have because we are not the first, but we are following Wazero, of course. And there are a bunch of things that you can do to make it easier to write a language native runtime in your preferred language, actually. So even outside of Go or the JVM. And the first thing that we did was to generate code for the opcodes, keeping them in a TSV format, which is very portable and very readable across different languages. We keep a Wasm corpus, so programs written in different languages and in Wasm as well, and compiled to Wasm in a folder so that we know that we won't have regression over those programs because we will run them on top of Chicory during the tests. And we are super heavily using native tools like Maven plugins for automating the whole of it. And in the Maven plugins, what we are doing the most is running code generators. So we have only 13,000 lines of code committed to GitHub, but at the end of the day, when you run the tests on your machine, you have over 250,000 lines of code that are just generated tests from the test suite. And this is actually a really powerful thing that we discovered and that speed up the development of a language native runtime. Those are the steps that you will need to follow if you really want to go down this path and integrate the test suite for writing the runtime. So first of all, there is a TCK for WebAssembly, which is the WebAssembly test suite. You have to download it. The WebAssembly test suite contains a number of WAST files. Those WAST files are basically an extended representation of the text format of Wasm. And since we don't have a text parser just yet, but we have just a Wasm binary parser, what we have to do is to download external tools like WAST to JSON to transform those WAST files into something that we can read and generate code out of them. So we download WAST to JSON as well. We run WAST to JSON on top of the WAST files. This generates a folder which contains the Wasm modules in the binary format and a JSON file that represents basically the assertions and the operations that you want to do against the compiled WASM files. And just parsing the JSON and treating it as an AST and generating assertions out of it is the way to go for us for generating JUnit code so that we can actually really use a debugger for debugging each and every instruction and each and every assertion coming from the test suite. So next, I really want to speak about the use cases for this technology because they were really, really, really unexpected even for us. I mentioned I mentioned that I work for Red Hat, so I sent an internal email to our colleagues saying that I was starting and collaborating on this project, and this was actually cool because people from the JRuby team reached out and said, "Oh, we have a problem for you," and I was like, "Are you sure?" And this was really interesting, but it makes a lot of sense. I know you're tired, but bear with me, and it makes sense. So Ruby is an extremely difficult program to language to parse because its syntax is super, super complicated, and it enables you to do a lot of stuff, but it's super complicated to parse. So what they are doing is re-implement a Ruby parser in pure C so that it will be the foundation and the official parser for all of the Ruby implementations from now on. And that's why Prism born. And then we have JRuby, which is Ruby on the JVM, as you might expect. But Ruby is a very, very, very C community. So most of the things that they are doing after the interface that you see in Ruby, they are actually implemented in C. So you need to ship and execute native libraries for running the code that is actually there. And in JRuby, they always had this problem that they share with the rest of the Ruby implementation, but they really didn't want it to have because one of the obvious advantages of running Ruby on the JVM should be that you don't have native dependencies. Again, back to the initial point. And they can't really bootstrap because even the parser, just trying to parse a Ruby program, needs an external library. And this is a problem for them because they need to know your architecture, and this is not portable. And then you have to cross-compile your application for different architecture. And if it is like a new ARM, maybe it's not supported yet by the parser, by the library, and you have to recompile your library, and so on and so forth. And actually, Prism can be compiled to Wasm code. And it is already running in JavaScript, for example, for showing the AST of Ruby programs. And what we did was to take this compilation target for Prism and make it run into Chicory. So you just download a dependency, which is super lightweight and which is super easy to import. And that's just plain Java bytecode that you will be able to execute on any JVM without downloading nothing that is specific to the machine you are executing on. Basically, what we are solving is the bootstrapping problem. So people won't have to download any external dependency, any additional stuffs to actually run any JRuby program on top of the JVM to bootstrap the environment. We are slower, yes, much slower, but still this works and this enables more use cases. Now, let's move to more interesting use cases. And I want to elaborate on this one because when I got hired in Red Hat, I was part of the Klock team. And Klock is a very popular identity management software. It enabled you to do single sign-on, basically, and all those kind of operations. But what you don't know is that this is like spaghetti code all the way down, and it is made for integrating any kind of legacy system. You can have Active Directory on one side, LDAP, and then Kerberos, and things like that. You don't. I know that you want to rewrite things in Rust, but you don't want to rewrite those integration in Rust. I'm sure. And this is the power, actually, of Java. Those enterprise applications, you can't really get rid of them easily in any way. So you want to actually empower them and enjoy their usage in different ways. And maybe what you don't want to do is to write a Java plugin because you really need to do something custom in Klock. And in Klock, what they have is what you expect. So if you want to match, for example, and check the identity of a user against the different providers, or to verify his identity, inserting some custom rules for your business, what you have to do at the moment is, as I told you, to write a Java plugin. But why? There is no real reason. And now we're just importing a library, and it took me like 2 hours to do a very initial proof of concept. So just importing a JVM libraries, you will be able to write your plugins in any language that compiles to Wasm, like Rust, C, Go, or Java, or JavaScript, or whatever. And this basically makes those applications, which are enterprise and heavy, etc., easily extensible with a system which is really, really lightweight for the project itself. Because for them means just importing a library and making it you able to load a file and to load some Wasm code in it. And this is super useful. So basically, there are a lot of more use cases that we have exploited with various level of POCs. But making this extension mechanism is making you able to scale the extensibility and the complexity of your applications. So Apache Camel is a very, very popular integration framework. They enable the producer for producing and transforming data into the integration that they are doing. With Wasm. It was extremely easy, is extremely useful because normally what you do is, again, customize with Java, and this is enterprise software that can be sold and supported by big companies. But now you have even a Wasm module, so you will be able to run Rust code there, and C code or Go, whatever, to just do your integrations without touching the Java part of it. Kafka, I know that you heard about it. With Kafka connected, you can perform transformations, and with Croxed issues is a proxy to Kafka, and you will be able to do filters. So you ingest messages coming on a topic, and you can transform them and perform some operations like encoding, decoding, encrypting, and whatever on top of, or routing even on with a proxy. Pulsar, another very, very well-known Java project, which is a message queue that is used all around. So. Last but not least, I want to talk about our roadmap. So it's just 6 months. The project is still really early, and it's still a lot of fun to join and to program on it. So first of all, we want to make all the tests green with the interpreter of the test suite. For now, we have excluded the SIMD support because we don't have capacity for tackling even it, and it will require Java 21 with a vector API. So a few more additional complications will be down the road, but this will be the first goal. But we are already mostly there, like more than 90% of the tests are already passing, so there are just a few bits to be fixed at the end. We want to implement the validation logic. We cannot claim to have a secure runtime, a secure and sandboxed runtime until we implement the validation part of the WebAssembly specification. And unfortunately, to just enable the first use cases and to make it real to run something on top of Chicory, we just skipped this part so far, and we are starting to implement all those validations logic that will be throwing exceptions all around in the codebase. And yes, we want some WASI preview and support because we want to be able to perform easily operations, for example, on files, because this is a very, very common use case that we have had so far. And at the end of this journey, we can claim we have a runtime that will be able to safely run your programs and that conform to the specification, and we want to tackle some performance improvement. We are sure that there will be a lot of low-hanging fruit and a lot of other things that we can do, even if it is just an interpreter, to improve performance over the current over the current code base. And last but most exciting that we want to get to is an NLT compiler. So we just started with an interpreter to have a solid base and a solid understanding of the WebAssembly specification. It's a journey for us as well into learning and understanding each and every detail of the WebAssembly specification. As soon as we are done with an interpreter and it will deliver, we will be able to actually translate Wasm code directly to Java bytecode. And we do expect to make this fast, or that's our desired goal. So just to show you that I'm not doing something, I'm not claiming something that is not real. This is, for example, running llama2.c. So llama2.c, you have seen in a couple of talks before this one, that is inference, etc. This is running on pure CPU, so it's extremely slow. You can see that it will take time to get something out, but yes, it's working, it's running in the background. So I mean, this shows that there are actual real workloads that can be run. Probably we should improve over them, but yes, there is something and is moving. And very last but not least, I want to thank all the contributors, because we are lucky enough to have a lot of great colleagues and people contributing to this code base. And I really want to encourage you to come and join this community of amazing people in this early project that we are enjoying a lot to develop and to bring to you. Yes, I think we have 4 minutes for questions.
Hats off for Reveal.js. It's the first Reveal.js presentation that I've seen, weirdly. Also, great T-shirt, and that's why I'm going to ask you this question. What's the overlap, and how do you compare the work that you're doing to, I think, the GraalVM Wasm support that they have? That I don't know very much about.
No. In GraalVM, what they built is basically a just-in-time compiler for any platform with Truffle, which is an API for letting you write an interpreter for any language. And in particular, they have an interpreter for Wasm, which is called Truffle Wasm, that runs on the GraalVM. Just recently, they made this available on any JVM. So this is portable, actually, even. It was not the case a few months ago. But now you can port it around with some penalty on performances, etc. But you can port it around. So kind of the goals are similar, but you have to bring with you an entire just-in-time compiler. And we are aiming for simplicity and to keep the dependency really with as little code as we can and make it light and easily portable to any JVM. So kind of same goal, kind of same way of execution, different trade-offs in the implementations, I would say.
So I think you answered my question. It's also going to be about Truffle.
Yeah.
All right, well, thanks for sticking around. Really appreciate it.